Alright guys, welcome to this page of the notes, and what we did in the previous videos is we took a look at a little bit of review when it comes to simplifying expressions with exponents and how we use the properties of exponents that you guys learned in Algebra 1 to simplify expressions. What we want to do now is take a look at that second objective or learning target where we're now going to begin to perform operations on polynomials. Specifically, we're going to look at addition, subtraction, and multiplication. But before we actually do any of that, I just want to review with you. We have looked at this already here in Algebra 2 in a previous chapter, but just refresh with you, you need to be able to determine whether it's actually a polynomial or not. And you'll need to be able to figure out the degree of that polynomial if it is a polynomial. So let's just quickly review how you do that. First of all, the degree of the polynomial, just highlight this whole thing, degree of the polynomial is equal to the degree of the monomial that has the largest degree. So you're going to go through, you're going to find the degree of each term in the polynomial. Whichever one of those terms has the largest degree, that will also be the degree of the polynomial. Again, I know that's kind of a wordy way of saying it, but when we do an example problem, it'll make perfect sense. It'll come back to you. And then, again, the things you're looking for, right? It's a polynomial, right? As long as it does not have, cannot have, square root, negative exponent, division by a variable, okay? If it has any of those things, it is not a polynomial. It is not a polynomial. So if you see a square root, not a polynomial. If you have division by a variable, not a polynomial. If you have a negative exponent, not a polynomial. Okay, so we got to check to make sure it doesn't have any of those things. As long as it doesn't have any of those things, it's a polynomial, you can find the degree. So let's practice a couple right here. I got a couple of expressions for you. I want you to figure out if they're a polynomial or not, and then if they are, figure out the degree. So here's what I got. I got 1/4 x to the 4th y cubed minus 8x to the 5th. First, if this is a polynomial, it has two terms. This is the first term. This is the second term. Remember, terms are always separated by addition or subtraction. All right, addition or subtraction separates terms. So I have two terms, the first term and the second term. Now, the things I'm looking for, I can't have any square roots. I don't. I can't have division by a variable. Careful, I have division by 4. Right? I have a 1/4. But 4 is not a variable. 4 is a number. It's a constant. So we're good. I don't have division by any variables. It checks out. Then I got to check to make sure I don't have any negative exponents, which I don't. So this is a polynomial. So now what I need to do is figure out the degree of the polynomial. And if you remember, here's how we do it. Again, that definition. You figure out the degree of each of the terms. Well, the way that works is you just sum the degrees, the powers of each of the variables. So I have an x to the 5th. That means that this term is a 5th degree term, or a 5th degree monomial. So that is 5th degree. I have an x to the 4th and a y to the 3rd. Add the exponents. 4 plus 3 is 7, so this is a 7th degree monomial. Well, our definition for the degree of a polynomial says the degree of the polynomial is equal to the largest degree monomial. Well, my largest degree monomial is a 7th degree, so my polynomial is also a 7th degree polynomial. So it is a polynomial, and it is 7th degree. Let's try a couple more. Oh, right away I take a look at B, I recognize the square root. This is not a polynomial. So don't even bother finding the degree. It's not a polynomial. We don't care. Let's go ahead and try another one. Oh, right away I take a look at C. It should immediately jump off the page at you. I got negative exponents. Not a polynomial. All right, so don't even bother finding the degree. We don't care. It's not a polynomial. Holy cow, what's 3 in a row. I take a look at this one, it should immediately jump off the page at you. I have division by a variable. That is not allowed, so this is not a polynomial. We are striking out here. Let's see, hopefully our luck changes. Take a look at the last one. Okay, well, I don't see any radicals, square roots. I don't see any negative exponents, and I don't see division by variables. So we're good. This is definitely a polynomial. Now, what kind of polynomial is it? Well, I have one term, two terms. Okay, I have 3 terms, so this is what we would call a trinomial. Because I have 3 terms. So it is a polynomial, specifically a trinomial. I have 3 terms, and in order to figure out the degree, I just need to go through and find the degree of each of the terms. Add the exponents on the variables. X to the 5th and a y to the 1st. 5 plus 1 is 6. This is a 6th degree monomial. X to the 4th, y to the 3rd. Well, 4 plus 3 is 7, so that is a 7th degree monomial. X to the 1st, y to the 1st, 1 plus 1 is 2. That is a 2nd degree monomial. And the degree of the polynomial is equal to the largest degree monomial, which is, of course, 7. So once again, I have a 7th degree polynomial, which in this case is actually a trinomial. All right, now that we've taken care of that and just reviewed how do you figure out if it's a polynomial and how do you find the degree of that polynomial, head on over to the next page of the notes. We'll actually work on adding, subtracting, and multiplying polynomials, so I'll meet you over there.